Hello friends, I welcome you on my channel Engineering Mathematics djganit. In this lecture we are going to discuss inverse of a matrix by Gauss-Jordan method. So first we recall what is the meaning of inverse of a matrix or invertible matrix. So as we know, we can define inverse for a square matrix only. So suppose capital A is a square matrix of order n. If there exists another square matrix capital B of this same order n such that A into B equal to B into A equal to identity matrix of order n, then this matrix capital A is said to be invertible or non-singular matrix, and this capital B is known as inverse of matrix capital A. Also, if B is inverse of matrix A, then A is also called inverse of matrix capital B. So if A into B equal to B into A equal to identity matrix, then this A and B are known as inverses of each other. Now for matrix A, if no such matrix capital B can be found out, then capital A is said to be singular or it is not invertible. So here we can see we have taken these two matrices. Capital A is a matrix of order 2 and capital B is another matrix of order 2. And here if we multiply A and B either from left hand side or right hand side, then we can see multiplication is identity matrix. So here capital A and B are inverses of each other. So to find out inverse of a matrix, we have seen adjoint method, or you might have understood adjoint method in your school class, but here we are going to discuss inverse of a square matrix using Gauss-Jordan method. So we discuss the method with the help of example. So we discuss find inverse of a matrix capital A using Gauss-Jordan method for this matrix capital A. So the idea of the method is we have to first construct a new matrix. So we start by constructing a new matrix, and we have to construct new matrix by writing two matrices. We take partition here. On the left side of this vertical line we write original matrix, and on the right hand side we write identity matrix of the same order. Here capital A is matrix of order 3, so in parallel we will write identity matrix of order 3. So first we write matrix A on the left hand side of this vertical line, and in parallel we have to write identity matrix of the same order as the given matrix. So here given matrix is of order 3, so in parallel we write identity matrix of order 3. So the first step is to construct a new matrix in this way, the matrix capital A with identity matrix of the same size. Now we have to convert this matrix into reduced row echelon form. Now to convert this matrix into reduced row echelon form, we will apply elementary row operations, and the elementary row operations which we require to convert matrix A into reduced row echelon form, those operations will be applied to this whole matrix. The operations which we will apply to find out reduced row echelon form of this matrix A, those operations we have to apply for the whole matrix which we have constructed. So what will happen when we will try to convert this matrix capital A into reduced row echelon form? In parallel we will be having changes in this matrix also. So after this matrix capital A is reduced in reduced row echelon form, we will obtain some another matrix on right hand side. So by Gauss-Jordan method, that matrix is nothing but inverse of given matrix. So we will convert this matrix capital A into reduced row echelon form. So here suppose capital R is the reduced row echelon form of this matrix capital A, and the operations which we will apply to find out reduced row echelon form of A, those operations will be applied to this matrix, whole matrix. So this matrix on right hand side will also change, and once we obtain reduced row echelon form here, whatever matrix we will obtain on the right hand side, that will be the inverse of the given matrix. So this is the idea of Gauss-Jordan method. We have to start by constructing a new matrix in this way, capital A in parallel identity matrix, and then we have to apply elementary row operations to convert this matrix capital A into reduced row echelon form, and those operations will be applied to whole matrix. So now we start by applying elementary row operations to this matrix. So we start with first non-zero entry of first row. It is already 1, so we have to make these two entries 0. So to make these two entries 0, we have to make this entry 0, we have to multiply first row by -2 and add in second row. Similarly, we have to multiply first row by -1 and add in third row, so that we obtain 0 here. So here second and third row will change. Here I have to write 3. So we write first row as it is 1 2 3 1 0 0. Now we multiply first row by -2 and add here. So 1 into -2, which is -2 plus 2 0. 2 into -2 -4 plus 5, which is 1. 2 into -3, 3 into -2, which is -6 plus 3, which is -3. 1 into -2, which is -2 plus 0, that is -2. 0 into -2, which is 0 plus 1. 0 into -2, 0 plus 0. Then we multiply first row by -1 and add in third row. So 1 into -1, which is -1 plus 1, 0. 2 into -1, which is -2 and plus 0. So we have -2. 3 into -1, which is -3 plus 8. So we obtain 5. 1 into -1, which is -1 plus 0. So we have -1. 0 into -1, 0 plus 0. 0 into -1, 0 plus 1. So you can see while applying these elementary row operations, the matrix on right hand side also changes. So this is the first non-zero entry of this matrix. Other entries in this column are 0. Now we check this entry. The first non-zero entry of second row is 1. So using second row, we have to make these two entries 0. So to make this entry 0 using second row, we have to multiply second row by -2 and add in first row. And to make this 0, we have to multiply second row by 2 and add in third row. So now first and third row will change, and before that we write second row as it is 0 1 -3, here -2 1 0. We multiply second row by -2 and add here. So 0 into -2, 0 plus 1, so that is 1. 1 into -2, which is -2 plus 2, that is 0. minus 3 into minus 2, that is 6, plus 3, which is 9, minus 2 into minus 2, which is 4, plus 1, which is 5, 1 into minus 2, which is minus 2, plus 0, 0 into minus 2, 0, plus 0. Now we multiply second row by 2 and add here. So 0 into 2, 0, plus 0, 1 into 2, 2 minus 2, 0, then minus 3 into 2, minus 6, plus 5, which is minus 1, minus 2 into 2, minus 4, minus 1, which is minus 5, 1 into 2, which is 2, plus 0, 0 into 2, 0, plus 1, so we have 1 here. So now we can see this is the first non-zero entry of first row. All the entries below this entry are 0. This is the first non-zero entry of second row. All the entries above and below this entry are 0. And now we come here, this is the first non-zero entry of third row, so it must be 1. So to make it 1, we multiply third row by minus 1. So minus 1 times third row. So only third row will change. 0, 0, 9, 5 minus 2, 0. And we write first two rows as it is, minus 2, 1, 0. We multiply each entry of third row by minus 1. So here minus 5 into minus 1, 2 into minus 1, and here minus 1. So here we have to write symbol of equivalence. So now here we have 1. So we write 1 here. So now this is the first non-zero entry of first row. This is first non-zero entry of second row. All the entries below and above these entries are 0. This is the first non-zero entry of third row. It is made 1. Now we have to make these two entries 0. So for that we have to multiply third row by 3 and add in second row, so that we obtain 0 here. Similarly, we multiply third row by minus 9 and add in first row to obtain 0 here. So third row remains as it is, 0, 0, 1, 5 minus 2 minus 1. We have to multiply third row by 3 and add here. So these two are 0. So we have 0, 1 as it is, and 1 into 3, which is 3, minus 3. So we obtain 0. Then 5 into 3, 15 minus 2, that is 13. Minus 2 into 3, minus 6, plus 1, minus 5. Minus 1 into 3, which is minus 3, plus 0. So we obtain minus 3. Similarly, we multiply third row by minus 9 and add here. And these two are already 0. So these two entries will be as it is. And 1 into minus 9, which is minus 9 plus 9, 0. 5 into minus 9, that is minus 45 plus 5. So we have minus 40. Then minus 2 into minus 9, which is 18 minus 2. So we obtain 16. Minus 1 into minus 9, which is 9 plus 0. So we have 9. And we can see on left hand side, we obtain reduced row echelon form of given matrix capital A. So, and it is nothing but identity matrix. So here we can write this is identity matrix, and the right hand side is nothing but inverse of given matrix. So therefore inverse of given matrix is nothing but -4 0 16 9 13 -5 -3 5 -2 -1. So in this way we can easily obtain inverse of a given matrix by using Gauss-Jordan method. We again discuss the steps of the method. These steps will remain same for each matrix. We start by constructing a new matrix. So we have to construct new matrix in this way: capital A partition with identity matrix. The order of identity matrix is same as the order of given matrix. Here given matrix is of order 3, so we have written identity matrix of order 3. Now we have to convert this matrix capital A into reduced row echelon form. So whatever operations are required for converting capital A into reduced row echelon form, those operations we have to apply for this whole matrix, and due to those operations there will be changes in this identity matrix also. So once our matrix is converted into reduced row echelon form, we will have another matrix on the right hand side. So that matrix is nothing but inverse of a given matrix. Now during this process, suppose we obtain 0 rows somewhere in the reduced row echelon form. Suppose in the process of converting capital A into reduced row echelon form, suppose we are obtaining one row as 0 row on left hand side, then we will stop the process and we will write down that inverse does not exist. So we can decide the existence of inverse also by Gauss-Jordan method. So we consider this note: in Gauss-Jordan method, if we obtain a 0 row on left hand side matrix of this whole matrix, then inverse of A does not exist. We consider inverse of this matrix also. So as we have discussed, we have to start by constructing a new matrix. As we have discussed, that new matrix is nothing but original matrix written with identity matrix. So here original matrix is 1 6 4 2 4 minus 1 minus 1 2 5, and in parallel we write down identity matrix of order 3: 1 0 0 0 1 0 0 0 1. Now we try to convert this matrix on left hand side into reduced row echelon form. So we start with first non-zero entry of first row. Here it is 1, and using this first row we make these two 0. So required operations are: we have to multiply first row by -2 and add in second row to make this 0. Similarly, we have to multiply first row by 1 and add here to make this 0. So second and third row will change. We write first row as it is. We have to multiply first row by -2 and add in second row. So 1 into -2, which is -2 plus 2, 0. 6 into -2, that is -12 plus 4, which is -8. 4 into -2, which is -8 minus 1, so we obtain -9. 1 into -2, which is -2 plus 0, that is -2. 0 into -2, 0 plus 1. 0 into -2, that is 0 plus 0. Now we have to multiply first row by 1 and add in third row. That means we have to add first and third rows. So 1 minus 1, 0. 6 plus 2, 8. 4 plus 5, 9, 1 plus 0, 1, 0 plus 0, that is 0, and 0 plus 1, which is 1. So this matrix is equivalent to this matrix. Now we concentrate on the first non-zero entry of second row. So we have to make it 1. But before making this 1, we can see if we add second and third row, then we will obtain 0 row. If we multiply second row by 1 and add in third row, then we will obtain 0 row here. So we apply this operation and we check 1 0 0. First and second row remains as it is, minus 2 1 0. Now we add these two, so we obtain 0 0, minus 8 plus 8 0, minus 9 plus 9 0. Here minus 2 plus 1, which is minus 1, 1 plus 0 1, and 0 plus 1 1. So here we obtain 0 row at the bottom of the matrix. So we stop here and we can write that since we obtain a 0 row on the left hand side, inverse of A does not exist. On left side, A inverse does not exist. So this is very easy method as compared to adjoint method. You can just construct the new matrix and try to convert your original matrix into reduced row echelon form, and whatever matrix you obtain after converting your matrix into reduced row echelon form, that matrix is nothing but inverse of given matrix. And be careful while doing this process. If some row, if you obtain 0 row anywhere on the left hand side, then A inverse does not exist. So I hope you are able to understand this Gauss-Jordan method of finding inverse. Thank you very much.